Hello and welcome to the Unit 3 Section 2 video on solving quadratics by factoring. So in the last section we talked about solving by graphing, but we can only do so much with graphing to be able to solve quadratic equations. So we need a better way to get more exact answers. And we can do that by factoring. So let's cover first the zero product property. A quadratic equation in one variable can be written in standard form. And this is the form that we are using most often in this unit. ax squared plus bx plus c equals 0. Now remember, if you have vertex form or intercept form, you can rewrite it into standard form. And again, a cannot be 0 because if a is 0, that term goes away and we're left with a linear equation, not a quadratic. Well, we can use factoring to solve certain quadratic equations. Now we can't do it to solve all of them, but we can use it to solve some of them, and that does help us get a little bit better than we were with graphing. The solutions of a quadratic equation are called the roots or zeros of the equation. We covered that in the last section. If the left side of ax squared plus bx plus c equals 0 can be factored, then the equation can be solved using the zero product property. The zero product property. And what this property really says is for any real numbers a and b, if a times b equals 0, then a equals 0 or b equals 0, or really both of them could be 0, okay? But at least one of those two terms being multiplied together has to be 0 for it to be true, okay? So let's factor this particular quadratic. We have x squared minus 18x plus 32 equals 0. First, we're going to factor the quadratic expression. And that can be factored by finding two numbers that multiply to give us 32 and add to give us negative 18. And those two numbers are negative 16 and negative 2. And so we factor it as such. Well, now that we factored it, we know that either this first term, x minus 16, has to be 0, or x minus 2 has to be 0 to make this statement true. So we're going to split up those two parts and solve each of them independently to find out what our x values are. And we can very easily find that x is either 16 or x is 2. So if you put either of these values into your original equation, you will end up with a true statement. It will equal 0. So you see here that two solutions occurred, so this quadratic has two roots. Okay, let's do a few examples of this. We'll start with x squared plus 7x equals 0. Well, we have a greatest common factor here that we can factor out, and that's x. So we have x times x plus 7 equals 0. We can split this up into x equals 0 or x plus 7 equals 0. You'll notice that this left one is already solved. The other one only takes one more step to solve. X equals negative 7 when we subtract 7 from both sides. And so our two solutions are x equals 0 and x equals negative 7. For b, we have x squared minus 6x plus 8. Well, this one we can factor by finding two numbers that multiply to give us 8 and add to give us negative 6. Those two factors are negative 2 and negative 4. So you have x minus 2 times x minus 4 equals 0. And then we're going to set each of these separately equal to 0 using the zero product property. And so x equals 2 or x equals 4. Those are our two solutions. All right, for c here, it may not be immediately obvious. You may look at this and say we've got to multiply 4 and 32 together or negative 32 together and find the numbers that multiply to give us that and add to give us 8. But if you notice, each of these is divisible by 4. So we can factor out a 4 first, giving us x squared plus 2x minus 8. And then we can factor what's left in this parentheses. So you've got 4 times x plus 4 times x minus 2. Because we found two numbers that multiplied to give us -8 and add to give us 2, and those were 4 and -2. Now we're going to split up this part and this part. The 4 will kind of just sit out here by itself. In fact, if we divided both sides by 4, then it would just go away, right? Because 4 divided by 4, that gives you 1 on this side. 0 divided by 4 on the other side gives you 0. But what we're concerned with is what values of x make it 0. So we'll set x plus 4 equal to 0, and x minus 2 equal to 0. X either equals -4, or it equals 2. Both of those would give you 0 as an answer when you plug it in. All right, for D, we want to recognize D as being a special type of factoring. And that special type of factoring is it's a difference of squares. So since it's a difference of squares, we can just simply take the square root of the first, which is 2x, and the square root of the second term, which is 3, and we'll set it into our two sets of parentheses. One will be added together, the other will be subtracted, and it's equal to 0. That's how we handle our difference of squares. So now we're going to split this up. You've got 2x plus 3 equals 0, and 2x minus 3 equals 0. Let's solve this first one. We have 2x equals -3, so x equals -3 halves. For the other one, we have 2x equals 3, so x equals 3 halves. So our answer for this one is -3 halves and 3 halves. Those are both answers that will give us a solution. And it makes sense that we have the same number but just a different sign, because the only thing this is getting plugged into is your square term, right? You have an x squared term. Well, 3 halves squared is going to give you 9/4. -3 halves squared is also going to give you 9/4. Because when you square a number, it's always going to be positive on the other end. All right, going on to E, you may recognize this one as a perfect square trinomial. If you take the square root of the first and the square root of the last, you get the two together being 6x. If you multiply it by 2, you get 12x, and that's the middle term. So if you recognize it as a perfect square trinomial, you can go ahead and write the square root of the first, square root of the last. The middle term is negative, so we're going to put a negative in between, and you can square it. This one doesn't have to be split up, because what happens if we take the square root of both sides? Well, we end up with what's left here on the inside of the square, because the square root of a square cancels. Square root of 0 is simply 0, and then we add 6 to each side, and we find that x equals 6. So if you were to graph this particular equation, you would find that you have one solution, and that one solution is the vertex, and the vertex is at 6, which means our axis of symmetry is also at 6. Okay, x equals 6. In fact, anytime you have a perfect square trinomial, you will have one solution, and that solution for x will be located along your axis of symmetry. All right, let's do F. This one's going to take a little bit more work because we can't factor anything out. So we're going to have to take 6 times 7, which is 42, find two numbers that multiply to give you 42, and add to give you -17. Well, those two numbers are going to be -14 and -3. So we're going to split up that middle term as such. So we'll do -3x here, and we'll do -14x here. So all I did was split up the -17. And when I did that, now I can factor by grouping. So let's group the first two terms. What can we factor out? We can factor out 3x. That leaves 2x in the first term minus 1 for the second term. Now we know we want to end up with 2x minus 1 out of this one. So what can we factor out to make that happen? Well, you can factor out a -7. Negative 7 times 2x gives you negative 14x. Negative 7 times negative 1 gives you positive 7. And then we simply factor out the common factor here, which is 2x minus 1. That leaves 3x minus 7. And now that we have factored it, we can split up our two sides for our zero product property. So we have 2x equals 1. So x equals 1/2. And then we have 3x equals 7, which gives us x equals 7/3. And those are our two solutions for this particular quadratic equation. Okay, so some quadratic equations will necessitate being rewritten into standard form before we can factor them. So we're just adding one extra little piece to this, okay? We have to get something in standard form equal to 0, then we can do everything else the same. So let's take a look at the first example in example 2, example A here. So we have x squared plus 5x plus 5 equals 5. If we want to get rid of this 5 so that we have 0 over here, we just subtract 5 from each side. If we subtract 5 from each side, this 5 goes away and this 5 goes away. And we're left with x squared plus 5x equals 0. Now we can factor it. We factor an x out and we're left with x plus 5 here. And then we split it up. We have x equals 0 and we have x plus 5 equals 0. And x is negative 5. So our two solutions are x equals 0, x equals negative 5. For the second example here, we've got to move 49 over to the other side. So we're going to do x squared plus 14x plus 49, because we have to add it to each side, equals 0. Well, I recognize this as being a perfect square trinomial. You have x, you have 7x times 2 is 14x. So we can do x plus 7 squared equals 0. And we use the plus here because the second term is positive. Square root of both sides, you get x plus 7 equals 0. So in this case, we have only one solution. And again, every perfect square trinomial will result in one solution. So that's what we would expect here. Moving on to example C, we're going to move our 4x over to the other side, and we're going to sandwich it in the middle so that it's in standard form. Now we're going to factor this. Two numbers that multiply to give us negative 5 and add to give us negative 4. That's going to be negative 5 and 1. Now we can split it up. We have x minus 5 equals 0. X plus 1 equals 0. So x is either 5 or x equals negative 1. For example D, we're going to subtract 64 from each side. So that gives us x squared minus 64 equals 0. I recognize this as a difference of squares, so we're going to have x plus 8 times x minus 8 equals 0. And when you split it up, you get x plus 8 equals 0, x minus 8 equals 0. So x equals either negative 8 or it equals positive 8. On to example E. Again, we have to rearrange first. So we're going to have 3x squared minus 27x plus 24. Now you'll notice I did not subtract 3x squared from each side. I would prefer to keep my leading term positive if at all possible. Now here we can notice that everything can be divisible by 3, so we can factor a 3 out, which gives us x squared minus 9x plus 8. We factor this in the parentheses, two numbers that multiply to give us 8 and add to give us negative 9. That would be negative 8 and negative 1. So you have x minus 1 times x minus 8, and then we split it up. X minus 1 equals 0, x minus 8 equals 0. So x is either 1 or x is 8. For example F, we have an x squared on this side. Let's move it to the other side. That'll make it positive. And then we're going to rearrange the other two terms. So we have the x term first. And then we'll factor this. Two numbers that multiply to give us negative 48 and add to give us negative 2. That would be negative 8 and positive 6. And so we split it up. X minus 8 equals 0. X plus 6 equals 0. So x either equals 8 or x equals negative 6. And then in example G here, we have x squared. If we move the 2x over, okay, that's going to give us positive 2x. And then if we add 1 to each side, that's going to give us negative 24. So we need two numbers that multiply to give us negative 24 and add to give us 3, or I should say 2. And that is going to be 6 and negative 4. And again, we split it up. So x equals negative 6 or x equals 4. All right, let's do a couple more examples that are a little bit more involved. And they're a little bit more involved because the factoring is not quite as easy. Well, first we got to do a little bit of rearranging. So let's move 9x over to this side, but I'm going to go ahead and write it on the left-hand side. So we've got 2x squared minus 9x plus 4 equals 0. We need two numbers that multiply to give us 2 times 4, which is 8. Two numbers that multiply to give us 8 and add to give us negative 9. And that would be negative 8 and negative 1. So I'm going to split that up into 2x squared minus 8x minus x plus 4. All right, we factor by grouping. We can factor out a 2x on this first two terms, and we're left with x minus 4. And if we want an x minus 4 over here, we can factor out a negative 1. And then we have x minus 4 times 2x minus 1 equals 0. We split it up, and so you get x minus 4 equals 0, and 2x minus 1 equals 0. So x equals either 4, or we have to do a little work for this one. 2x equals 1, so x equals 1/2. So 1/2 and 4 are both solutions that will make that statement true. And then one final example to wrap up this section. So again, we're going to start by rearranging. So we'll have 2x squared by moving this over to this side, minus 15x. Subtract 6 from negative 2, you get 8, negative 8. And now we need two numbers that multiply to give us negative 16 and add to give us negative 15. And those two numbers are negative 16 and 1. So we're going to do 2x squared plus x minus 16x minus 8 equals 0. We can factor an x out of the first two terms, and that leaves us with 2x plus 1. We want a 2x plus 1 to come out of the other side, and we can achieve that by factoring out a negative 8. So we get 2x plus 1 times x minus 8 equals 0. We split it up. You get 2x plus 1 equals 0. You get x minus 8 equals 0. So 2x equals -1. So x can be -1/2, or x can be 8. And those are our two solutions. So you'll see that we can find our two solutions by factoring, but it's not always going to work because we're going to sometimes end up with something that can't be factored. And we'll be getting into what to do with that a little bit later in this unit. But in the next section, before we get there, we're going to review a topic that you'll need for that, and that will be simplifying radicals, and we'll even delve a little bit into imaginary numbers.